All right, Unit 8, Day 3. More with the 6 trig functions. But rather than drawing a triangle, we're going to be 6 trig functions on a plane. Not like a flying plane, but like the coordinate plane. 6 trig functions. So still Sohcahtoa and their partners, but done a little bit differently. 3 Roman numerals. Third one's the shortest. Six trig functions on a plane. That's the first Roman numeral, and the others are sort of applications of that. So that's probably not the best organizational, right, outlining. So let's say we got the point xy. And we want to make a triangle with that point. Step 1, draw a line from the origin to the point. This is making a triangle on the coordinate plane, just given a point. So plot the point. I guess that would be step number 1. Step number 0. Plot the point is step 1. Step 2 is draw a line from the origin to the point. All right, I mean that makes sense. Like nobody misses that. Step 3 is the crucial step, is that you always connect the point to the x-axis. Always connect the point to the x-axis. Okay, sometimes it's tempting, and I intentionally drew mine this way. Like, it would be closer to go to the y-axis, but you don't ever go to the y-axis. You always connect the point to the x-axis. Because, you don't have to write this down, but because the angle is always measured from the x-axis. So that will put your angle usually inside the triangle. Talk about usually in a minute. So now our triangle has sides of x and y and r. You can call it h if you want, but usually we call it r in this situation, although it's the same thing as h. And a squared plus b squared equals c squared still applies. So you might have to do that to find r. All right, let's talk about Sohcahtoa here. But instead of O and A and H, we got X and Y and R. But Sohcahtoa still applies. So sine is opposite over hypotenuse. I guess we could actually write that as kind of a review. So for this particular problem, or problems where the triangle's on a plane, opposite is Y, hypotenuse is R. Cosine is adjacent over hypotenuse. Well, adjacent is x. Hypotenuse is r. Tangent is toa, opposite over adjacent. And for this setup, it's y over x. I'm not even going to write the others because the others are just the reciprocals, so it's not a big deal for the others. Now, there's a couple ways to remember this. Well, you'll have it for notes, open note test, so you'll be fine. But generally speaking, you can memorize, so you already know Sohcahtoa. You can memorize y over r, x over r, y over x. But it's probably best to just draw a quick picture and realize opposite over hypotenuse is y over r. Another way to think of it is that x is always the adjacent side, and y is always the opposite side. That's easy to remember because x comes before y and a comes before o. So like alphabetically, you shouldn't get them confused. X is always adjacent, y is always opposite. As long as you connected your point to the x-axis. If you connect it to the y-axis, you're going to get those backwards, you're going to miss everything. So connect the point to the x-axis. That will force, well, I don't know if it's like a chicken and egg situation. These two things go together. If you don't connect it to the x-axis, then these are backwards. So x always goes with a, y always goes with o. And then obviously r is the square root of x squared plus y squared. Pythagorean Theorem. So most of what we're going to do today, we've kind of already done. They're just going to look a little bit different because they're not going to start as triangles. They're going to start as points, and you got to figure out what the sine, cosine, tangent stuff is. So let's find the 6 trig ratios. For an angle through 3, 4. So we plot the point 3, 4. Maybe we should have made plotting points part of the warm-ups, right? Make sure we get our x and our y's correct. Draw a line from the origin to the point, and then from the point to the x-axis. And I'm going to label the sides. Oh, I was kind on this one. What's the hypotenuse for this triangle? What's the radius? Yeah, some of you are like 5. It's easy. Yep, we like it when they're nice. So sine, cosine, tangent. And again, you can think about opposite and adjacent, or you can think in terms of x and y. Usually I'll label them both as I'm working a test or something, so it helps me grade yours. And then that 5 is the R or the H, if you want to call it H, either one. So now that everything's labeled, it's just like what we did 2 days ago. It's just opposite over hypotenuse, adjacent over hypotenuse. It's the same stuff. So let's see, sine is, again, I don't really remember that it's y over r. I still remember that it's o over h, and I know who's o and I know who's h. So 4/5. Cosine is x over r, but I would rather remember that as a over h, as long as I know who a is, 3, and h is 5. Tangent is opposite over adjacent, 4/3. And then all of the reciprocal partners here, cosecant, secant, cotangent. But those are just flips, so I don't memorize anything with those. I just flip sine, and flip cosine, and flip tangent. And again, today the worksheet lays out the all 6 ratios, so that kind of helps you remember who's partners, because we're not trying to trick you. That would be cruel to sort of mix up the other side there, but we don't do that. So far, nearly identical to stuff we've already done. Let's do another one. Find the 6 trig ratios. Right? Like that's 2 identical. We need to do something that stretches us a little bit here. Find the 6 trig ratios through -3, 5. So we'll draw the point. -3, 5. Connect it to the origin. Connect it to the x-axis. Always, always, always to the x-axis. And then let's label the sides. This is where things get a little bit interesting, because this side length, well, the side length is 3, but we're still going to label it -3 because we went backwards 3. So that starts to feel a little bit weird. Like, wait a minute, you're telling me the triangle has a side length of -3? No, it's not really a triangle, but we need to label it that way to make Sohcahtoa work. The height is 5, so that one makes more sense. And then the square root of a squared plus b squared. Let's see, 9 plus 25 is 34. So square root of 34. So we got our picture. Where the angle is in this is a little bit strange. That's one of the tricky things. You don't even have to draw it, but the angle is always measured from the positive x-axis. So there's the angle, which seems a little bit weird, because if you want to go opposite of that angle, like, where do you go? There's nothing over there. So that's why opposite and adjacent don't make much sense. In fact, how would you do adjacent? There's not really an adjacent. So that's why we switch to x's and y's. X and y. But again, x is always adjacent, y is always opposite. If you remember that, then you don't have to worry about, well, what is opposite a weird angle and adjacent to a weird angle? Don't worry about it. Adjacent is always the x, opposite's always the y. And so you can label them like that, and then you can use Sohcahtoa. Sine tangent. And the partners. So why don't you see if you can finish those 6, and then we'll check them. So watching at home, press pause, finish them out, and then we'll see how you did. Hopefully you're already to the point where fixing these is really easy. Like, you don't even write out square root of 34 over square root of 34. You just do it, and you know what's going to be the result. Cosine is adjacent. You know what would help me if I labeled the triangle, maybe? -3 over root 34. So -3 root 34 over 34. So this introduces something that we haven't had yet, and that is sines, cosines, and tangents and their partners can be negative, and that's okay, because we're not in the first quadrant anymore where everybody's positive. We're now going to move out where we've got some negative stuff, or 2 negative things, or 1 negative thing. So it's okay that we get negative answers. Let's see, tangent is opposite over adjacent. And then just the flips. Hey, sometimes the flips are even easier than the originals, because there's nothing to fix. Questions on those? Did I breeze through those too quickly, or are those as simple as I made it look? Yes, no? No one objecting, so I guess we're okay. All right, let's take a minute to talk about something that you don't absolutely have to know, because it will take care of itself. But if you know it, it makes sense and will help you really the rest of this entire semester. So again, it's not something you have to memorize. Most students do memorize it because it helps them the rest of the way. So let's see. Sine is y over r. R is always positive, so you will never have a negative hypotenuse. Well, I should take that back. For now, we won't have negative radiuses. But if y is negative, so if we're in one of these bottom two quadrants, then our sine would be negative. So, this one's kind of weird. This is the sine of sine, the SIGN of SIN. Because sine goes with y, it's kind of a y-axis thing. So if we're above and y is positive, then sine is positive. Cosine is x over r. So let's look at the sine of cosine. Again, that sounds weird. The positive negative of cosine. Cosine goes with x. So if x is positive over there on the right, then cosine is positive. If x is negative over there on the left, then cosine would be negative. That's super important to know. Like, I made a deal like you don't have to memorize that, but it's very important to know. It'll help you the rest of the way with getting your pluses and minus right. Sine has to do with y, so it's an up and down thing. So if your triangle is up there, then sine's positive. Cosine is a left-right thing. It's an x thing, so on the left is negative and on the right is positive. Tangent is a little bit weird because it's y over x. So it depends on both x and y. So the sine of tangent. Well, in the first quadrant, everybody's positive, so that's an easy one. So tangent would be positive. Over here in the second quadrant, let's see, x would be negative, y would be positive. What would that do to the positive negative of tangent? If x is negative but y is positive, what's tangent going to be? If y is positive but x is negative, what's positive divided by negative going to be? Negative. Third quadrant, let's see, everybody's negative. Y is negative and x is negative. And that turns into a positive, so that's a little bit weird. The third quadrant, everybody's negative, but because tangent is a ratio of the two negatives, it turns out to be positive. And then in the fourth quadrant, let's see, y is negative, but x is positive. So the ratio is negative. So tangent's a little bit weird. It's positive in 1 and 3, negative in 2 and 4. Sine and cosine are a little easier to keep up with. Sine goes with y, cosine goes with x. Now, there's one little picture that'll make sense of all of that. And I will see this on test the rest of the semester, and that's okay. I still write it on my stuff when I'm working on it. Who is positive? Well, here's how we remember who's positive by quadrant. Let's see, in the first quadrant, they were all positive. That makes sense. Everything's positive in the first quadrant. Look back at those three pictures. Who was positive in the second quadrant? Sine, cosine, or tangent? Sine is positive. Cosine and tangent are negative in the second quadrant. Look in the third quadrant. Who's positive in the third quadrant? Just tangent, because two negatives make a positive. And in the fourth quadrant, who's positive? Cosine. Okay, remember these quadrants are numbered 1, 2, 3, and 4. We number them going around that way. So here's how most students remember who's positive where. All students take calculus. Yes. obviously not entirely factual statement, but it helps us remember all students take calculus. So on most of the tests going forward, I will see this little picture somewhere, and that's just a quick, easy reminder that first quadrant, everybody's positive. Second, third, fourth, who's positive in there. So that's a really good way to kind of check what you're doing. Again, you don't have to do that because it takes care of itself, but it's a real easy way to remember who goes where. All right, Roman numeral 2, reference angles. It's an easy thing to describe and a sometimes tricky thing to figure out. The reference angle is the smallest angle to the x-axis. And it's always positive. Smallest angle to the x-axis, always positive. This is part of why we draw the triangle to the x-axis, because it will make a reference angle. All right, probably the best way is to just do some examples of these. I guess we should maybe have some steps. To find the reference angle, draw the angle, and then get to the x-axis the quickest, shortest, easiest way possible. So 27 degrees. You know what? Maybe before we do that, maybe we should draw not all of the angles, but they're called the quadrantals, the main ones. So this is 0. We measure going around. That's 90. That makes sense, I think. What's halfway around over here? 180. How about halfway between, you know what, let's jump to the end. What's all the way around? 360. And then what's halfway between 180 and 360? 270. That's it in degrees. Let's now do it in radians. So 0 is easy. That's still 0 radians. Let's kind of go not in order. What's 180 degrees? That's what we did yesterday. How many radians is 180 degrees? Well, careful, 2 pi is all the way around. So 1 pi is halfway around. Which means at 90 degrees, what's halfway between 0 and pi? 1/2 pi, or pi over 2. So you don't have to memorize all of them. As long as you remember that all the way around is 2 pi, then you can kind of just start figuring things out. Well, halfway would be pi. Half of that would be pi over 2. This one may be a little tricky. What's halfway between 1 and 2? And this is why we did some of the fraction stuff as warm-ups. Halfway between 1 and 2 would be 1.5, but we'll write that as 3 pi over 2. All right, so now let's graph 27, figure out what the reference angle is. What's the quickest way to an x-axis from 27? So 27 is between 0 and 90. I don't have to be perfect. You don't need to get a protractor out and measure. No, just get it. As long as you get in the right quadrant, you'll be okay. 27 is clearly in the first quadrant. It'd be nice if you could draw it reasonably accurate. It's closer to 0 than 90. So I don't know what exactly it looks like, but I'm going to say that's 27. So the quickest way to the x-axis, this one's almost too simple. Well, I'm 27 degrees away from the x-axis. So the reference angle is the original angle. Sometimes it's that easy. Number 2, 95 degrees. For most of us, you're going to want to draw these pictures. If you've done a whole bunch of them, you might be able to start getting these without drawing pictures, but for a while, we're going to want to draw pictures. Let's see, 95. So that's a little bit past 90. Not much past 90, so something like that. The reference angle, though, is get to the x-axis as soon as possible. So that would be over here, would be the reference angle. So how far is it in terms of degrees? What was that? 85. How'd you get that? Yeah, so 180 minus 95 is 85 is our reference angle. $253 degrees. Now we're getting crazy. 253. Let's see. 0, 90, 180, 270. You don't have to label those, but if you need to, it's certainly okay. So we're into the third quadrant, closer to 270 to 180. So again, your picture doesn't have to be perfect, just as long as you land it in the correct quadrant. So the reference angle would be sort of backing up to 180. There's the reference angle. So how am I going to figure out what that reference angle is? Yeah, 253 minus 180 is the reference angle. So depending on what quadrant you're in determines how you figure out what your reference angle is. So there's, in some ways, 4 different ways to do it, but don't think of it that way. Just draw the picture and figure out how to get to the x-axis as soon as possible. The tricky part for these is when we go to radians, like 11 pi over 7. 11 pi over 7. So 0, pi over 2, 3 pi over 2. This is why we did those warm-ups. Where's 11 over 7 relative to those angles that I've got? I guess first of all, is it bigger than pi? Yeah, 11 over 7 is bigger than 1, so I know it's past there. How about relative to 3 pi over 2? Or somewhere between 180 and this one? I'm going to convert them all to over 7. I don't even know if you're right yet. You might be. If I convert them all to over 7, then this would be 14 pi over 7. This would be, that would be tricky to get that one to be over 7. It'd be, what, 9.5 pi over 7? No, it'd be 10.5 pi over 7. That's weird. So now what quadrant do we think it's in? 1, 2, 3, or 4? Now it's in 4. It goes past 3 pi over 2 just a little bit into the fourth quadrant. So what we want is to get back to the x-axis. So that would be 2 pi minus 11 pi over 7. Again, fractions are going to eat some people alive in this unit. So I need a common denominator. 14 pi over 7 minus 11 pi over 7 is 3 pi over 7. I go 11 over 7 and then 3 over 7, I'd be at 14 over 7, which is 2 pi. Again, I'm just going to trust that you know how to add and subtract fractions, because if you don't, this is going to be really, really tricky the whole way through. (13 pi over 12). 13 pi over 12. I think that one's a little bit easier. What quadrant is that one going to land in? Yeah, 3. Because it's a little bit bigger than 1. That's all you have to think about is, well, how does it compare to 1/2, to 1, and to 1.5? Well, it's bigger than 1. It's just barely bigger than 1, so I know it's just barely into the third quadrant. That reference angle. Can you tell what the reference angle is? Might help if you change this pi to 12 pi over 12. You got a common denominator there. So how much past 12/12 did we go? 1/12. So pi over 12 is our reference angle. Let's do one more of those, and then we got one more problem after that. Negative 3 pi over 4. The negatives will mess with some people. Negative means we got to go backwards. It also means we have to sort of measure backwards. So going backwards, this is negative pi. This is negative pi over 2. Negative 2 pi would be all the way around. So it's a little bit weird going backwards. Negative 3/4. So if I rotate negative 3 pi over 4, do you know what quadrant we'll land in? How does 3/4 compare to 1/2? A little bit more. How does 3/4 compare to 1? Yeah, not quite there. So somewhere into that third quadrant is where we'll land. Reference angle is still get to the x-axis as quick as you can. So right there. Can you tell what that angle is? So all the way back would be pi. We went to 3 pi over 4. So how much more did we need to go? 1/4 pi, or pi over 4. All right, let's just do one off the homework together here. And I'll do one of the evens because I posted the odds. So it's on the back of worksheet 3. Let's look at number 16. Find the value of all 6 trig ratios given the constraints. Some of you are going to like these because these are just kind of like puzzle problems, like figure out what works here. So cosine is 5/13. Okay, well cosine can be positive in 2 different quadrants. So we could be in quadrant 1 or quadrant 4. But if tangent is negative, let's see, that happens in quadrant 2 and quadrant 4. So we've got to be in quadrant 4. Does that make sense? Kind of blitz through that. So I've got to land in quadrant 4. I know that cosine is adjacent over hypotenuse, or x over r. So 5 and 13. What's my opposite side? You know this triangle? 5, 12, 13. Except that it's not 12, it's negative 12. And then I can answer all the questions because I've got my picture drawn. And maybe even labeled to make it even easier. So we'll do a couple of more of those tomorrow. Those are a little bit tricky until you get the hang of them. So 6 trig ratios through a point, find some reference angles, and then do some puzzle problems. The odd answers are not posted yet, but they will be soon. That was a long one today.